Hi, welcome to my video on changing exponential form to radical form. Exponential form is b to the m over n that we practiced in the previous video, but in the radical form for this exponential form, this is the root, n is the index, b to the m power. So notice the root is on the bottom n, and this is b to the m, or we could write it as n, the nth root of b, all in bracket raised to the m power. Either or, you can write it down either way. Sometimes it's good to write it this way, sometimes it's good to write it this way, depends. Change exponential form to radical form. This is the exponential form of b to the mn. We want to change it to, I'm going to change it to each one of these. So 2 to the 3/4, that your 4 is on the bottom, that's your index or your root, and that's 2 cubed. Or we could go with the 4, 2, all cubed. Either or will do it. 3 to the 1/2, the root is 2. 2 indicates square root, but we don't put it in. So that's 3 to the 1, or just the square root of 3. Or we could have the square root of 3 and raise to the 1 power, but again, that's the same as the square root of 3. 6 to the 5 over 3 as a power, and that's, again, the root is 3. 6 to the 5th power, or we could have it the cube root of 6 bracket to the 5th power. Either or, whatever way. Most times people write it this way, not too often this way. And we have the x to the 1/5, so the root is 5, the 5th root of x to the 1, again, which is just the 5th root of x. The 1 is understood. And the other way is the 5th root of x to 1 power again, which is just 5th root of x. E, we have 1/2 raised to the negative 3 over 2. So we could, before we start, make it as 1 over 1/2 to the 3 over 2. That's one way. Or let's deal with that one. So that means that we have 1 over, and the base, the root is the square root because of the 2. We got a 1/2 and we cube it. Or we could have it 1 over, and we could have the square root of 1/2 all cubed. But notice, because it's negative, I did the 1 over. Or, if you think about it, we could also do the negative exponent makes the reciprocal of the base, so that makes it a 2 raised to the 3 over 2. So if we remove the negative exponent flips the base around. So now we could have this, and that's the same as the square root of 2 cubed, or we could have the square root of 2 all cubed. So if we changed, because of the negative exponents, if we change the 1/2 to a 2, then you get these, which is perfect. Or this is a little bit, notice we got 1 over, because I didn't take the negative exponent of it. I kept the base as a 1/2. F, 5 to the negative 1/4, again, it's, you could, if you want, go 1/5 to the 1/4 power. Then you have no negative. So that's 1/5 base, 4th power on the 1. So putting the 1 here is not going to change it. And this one ends up to be the same, because when you raise it to the 1 power out here, you get the same expression. 7 to the 2/9 is the 9th root of 7 squared, or it's the 9th root of 7 all squared, either or. Again, the denominator is your index, is your root. That's the main one to remember. This is the root. This is the cube root. See? The denominator is your root. It's the cube root of 3/4 to the 1 power. And both of them become the same because raising it to the 1, putting a 1 here is not going to change it. Putting a 1 out here is not going to change it. Okay, let's continue. So we have some practice. Change exponential form to radical form. So what you can do now is pause the video and work these out. So here we go. Again, the base is b, m is 1, n is 4. So we have the 4th root of 3 to the 1. And we don't need to put the 1 in. And this one becomes the 4th root of 3 and raise it to the 1 power. It's the same expression. And we have the base is x, the root or index is 5, and we have a cube. Or we could have it, the base is x, fifth root, cubed. Number 3, we have the base is 2, the root is 4, sorry, the root is 7, the denominator. The root is 7, the power is 4. So we got the base is 2, the root is 7 to the 4th power. We got a 1/3, so the base is 2/5. The root is 3, cube root to the 1 power. Not necessary to put the 1 in. And doing it this way, you're going to get the same answer because when you put a bracket here and put a 1 on up at the top exponent, it won't change it. And the 5th one is, again, notice I put the base in. The base is 5, the root is 11, the power is 6. The base is 5, the root is 11, all raised to the 6th power. Just 2 different ways to write it. And we got 1/7, or 7 to the negative 5/4. So the way I like to write it is change the negative exponent to a positive and flip your fraction. So reciprocal of 7 is 1/7. So that makes the base 1/7. The root is 4, and it's to the 5th power. I had to put the 1/7 in a bracket when I raise it to the 5th power. I have to put the bracket in. I cannot write that. That only looks like 1 to the 5th power divided by 7. So I had to put the bracket in. So the base is 1/7. The root is 4. Raise it to the 5th power. Number 7. I gotta see a 10. Number 7. Again, the base is 10. 2 is the square root, but we don't put it in. Raise it to the 1 power. And both of them become the same. Again, 2 is the square root, so it's understood to be there. Raise it to the 1 power. And we got a negative exponent. Let's change the negative exponent to a positive exponent. And the reciprocal of 1/3 is the 3. So the root, the base is 3. The index is the 8th root cubed. Or we got 3 outside. Note, 3 to the half is, base is 3, 2 to the 1. That's square root. And this is the base 3 raised to the 1/3, so that's a cube root, root 3, cube root of 3 to the 1 power, so that's the cube root. And we have 3 to the 1/4, the base is 3, the root is 4 and 1, that's the, what they call the 4th root. And we got, again, 3 is the base, 5 is the root raised to the 1 power, that's the 5th root. and the ultimate one, or the one at the end. Base is 3 to the n. 1 is understood to be there. So this is the nth root. This could be a 6, a 7, a 10, 12, but that's the nth root. So that brings us to the end of this video on changing exponential form to radical form. If you like my video, click the like button, subscribe button, notification bell. Visit my website, www.mathfullyexplained.com, to find more information about me, my video, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.